And don't worry about, it being a question that you think, oh, should I know that? If you don't know it, you don't know it. So obviously ask away. Okay, so how can we tackle this question? Lou wants to look at a gym and sees two offers. Gym membership, all classes included, £44 a month plus a £30 joining fee. Pay as you go, no joining fee, £7.75, 75p per class. Lou wants to attend two classes each week for a year. She thinks if she's offer A, she will save at least 28% of the total cost of classes compared to using offer B. So when we look at that question, first of all, we've got to decide which one we're saving money on. So if she thinks if she joins this one, it's 28% cheaper than this one. So the first thing we got to do then is, because we can easily work that out, can't we? We can look at £44 a month and £30 joining fee. That's easy to work out. So if we work at this one, we work out how much it's going to cost and take away 28% and then work out this one. Or we can work out this one as a start and then work out that one and see if it's 28% more. But I would always think of this one. So I need this price for this class to be 28% cheaper than this one. If it's not, we're not right. It's not right. So let's go here. She wants no joining fee, £7.75 per class. Right, and she's coming to 2 a week times 2. And she's coming for a year. So let's presume we've got no holiday. She's going every single week of the year. That's going to give us the cost. And that will be our 100% value. We're going to do it on a calculator in a second. And then once we've got 100% value, we're going to take away 28%. Or if we think about it rationally, if we're taking 28 away from 100, it's leaving us with 72. So we need our 72% value of our 100% number. So once we've got that one, we can simply multiply it by 0.72. And that'll give us our 72% number, or as we look at it this way around, the number that's 28% less than the value of pay-as-you-go classes. Right, so let's have a look. She's paying £7.75 times by 2, so that's 2 classes a week, £15.50, and she's coming every single week of the year. She's going to cost, wow, sounds expensive, doesn't it? £806 for a class. £806 a year. Okay. Once we now times that by 72, times by 0.72, sorry, we've then got 72% of that value. If you wanted to just take away, so if your calculator looks a bit like this, and you can click take away 28%, so it even tells you what the 28% is there, and click equals, we can see that is going to be 580.26, I'm sure it said, 32, nowhere near 26. So on a calculator that works like that, that's absolutely fine. If your calculator doesn't work like that and you're not sure how to work the percentage button, let's be honest, we haven't probably used percentage button on a calculator since school, and even then we weren't really sure how to do it, so we didn't bother. The calculators now that my daughter has, or what if you've got kids, it's like, whoa, why do you need so many buttons on a calculator? There was not such thing when I was at school, really. But so we're going to go 806, that's our annual price, and we're going to do exactly what I said before. We're going to times it by, not taking away 28%, we're going to times it by how much we still need in a decimal format, so times by 0.72, and we've got the same price. So if you think about what I did there on a calculator, it took me one sum to work out the annual price, which was 806, and then we multiplied it by 0.72 and we got 580.32. That's one way. The other way we did it was we found out what the 806 was, took away 20% using the percentage button on the calculator, and then had 580. If we didn't know either of those ways, quite simply, we know this is our 100% value, 806, because it says that's our offer where it thinks this one's cheaper. So that's our 100% value. If we divide it by 100, Yeah, we've got what 1% is. And like I keep saying, once we got 1%, we can find out anything. So if we want to then find out what 28% is, because she says it's going to be 28% cheaper, we can times it by 28. Yep. And then we can take away that 28% from our 806. And we're still going to get £580.32. But it's a step-by-step process that if you're comfortable using, absolutely use it, because there's no point trying to teach yourself new ways of doing something when your way's comfortable and you understand the question. But I'm just giving people various ways of doing things. So we can see that 28% cheaper would be £580, 32p. So let's look at this one. She's paying 44 times by 12 because it's every month. And then we've got the £30 joining fee. Okay, so we know that 44 times by 12 add 30 equals 558,558. So when we say in here, she will save at least 28%. Well, when we take off 28% of that number, it still gives us 580. So look, it's even cheaper. So she's saving at least 28%. Doesn't ask you how much percentage she's saving. That's not this question. We don't need to work out that. We can just see that actually when she pays this fee here, she's paying 558, which is at least 28% cheaper than offer B. So we should think she should go to offer A. And that's the kind of question that gets people's brains thinking when they come to the start of the class. And it most probably would have been about a topic we did last week. So sometimes we do, why is that not let me go? It's coming down now. We focus on a topic the week before. And another question where we've got here, we're talking about that percentage increase. If I remember, a percentage decrease, I'm going to write the word no. And the reason I'm writing the word no is because full formula, new, take away original or old, I call it, divided by original. So we've got NO and NO. So if I write the word no, whenever I see a percentage increase or a percentage decrease question, I know the order I've got to put my numbers in. It doesn't give me the formula because that's this whole bit here, but it gives me a chance to remember which order my numbers are going to be in, and I can see that I've got an N and an O there, then I put another O there. Okay, now I'm going, and then I put a minus here, then times 100. So by remembering that word no, it gives me a foot up into remembering what percentage increase and decrease is all about. We've got here, look, calculate a percentage increase of number of people attending the festival or food event. The new number, so last year 550 people attended the event. This year there will be 748 people attending the event. Calculate the percentage increase. So I'm just uncrossing my legs again, a bit uncomfortable. So we've got a new number, 748. Remembering the formula, no, minus old number, 550, divided by, NO, old number, 550. So now we've created our own little fraction here. It doesn't look much like a fraction, but it is a fraction, because when we go top number divided by bottom number, it gives us a decimal. Always, doesn't it? And once we've got a decimal, we times it by 100, and it gives us our percentage. So by doing the numbers in that order, new take away old divided by old, it's looking like a fraction. That's your denominator, and that's your numerator. And then we times it by 100, and we got our percentage. So a question like that will be worth, if it's a straightforward question with numbers already written in like that, you're going to be looking at no more than 2 marks. Because they don't build the questions like that. Don't NCFE and Pearson don't either. They kind of smuggle a story in there, so you've got to kind of buy into what they're talking about. So we divide by 550, and we times by 100. So the percentage increase for people coming to our festival or food and drinks event this year is going to be 36% increase. Obviously over there, that's different numbers. So don't think, oh, you've got it wrong, Steve. It says 25 over there. They're just using different numbers. Talking about a plane ticket increase. That's just a question we've got there. Hopefully, now we'll be into the questions we're converting between numbers, some more practice questions. As you can see, I kind of get carried away sometimes with my practice questions, and it's a case of when it's a 3-hour class, we kind of wait and give people loads of time to do questions. I'm happy to do that. If people want to answer questions, I'm absolutely more than happy to do that. But I'd like to look at conversion. We see conversions in quite a few questions. We see gallons to litres. We see meters to feet. We see miles to kilometers. We see kilograms to ounces. No, we don't actually. Height. We sometimes see meters to feet when it comes to height. I'm trying to think of what else. Gallons to litres. We've said that one. So when we're talking questions that involve conversions, I'm not talking millimeters to centimeters because that's the same units, isn't it? It's just broken down a little bit smaller. So centimeters to meters is not really a conversion. You're just making that number, 100 centimeters in 1 meter. So you're just changing the unit at the end. You're still working with the same unit of measurement. It's just called something different. Whereas an inch to a centimeter, we're having to do something with that number to convert it. So we're talking where we're changing the actual word at the end of the question. Some questions, you'll see a conversion graph like this. We've had one on a mock question about the, oh my gosh, I think it was the shop one. We have to find out the area of the rubber matting. We have to go along and down to find out the conversion between feet and meters. So if it gives you something like this, it will always give you a little bit of wiggle room. It won't actually, say, oh yeah, it's 71 centimeters. If you say 72 or you say 70, they're still going to give you the mark because it's one of those questions where it'll be about a rounding up at some point in the question. So if you convert it and you're completely wrong, so if you're saying, right, use the graph, calculate how much 50 centimeters in inches, and you go up inches and go, oh wow, okay, oh yeah, it's 125. Then you've read it the wrong way around. It's asking you what 50 centimeters is in inches, and if we look at that one, we're going to go up at 50. I mean, I'm looking at it can't be any closer. I think that absolutely lands on 20. I mean, can't be any closer. So we say 20. How about 45 inches to centimeters? So it's getting used to going whichever way around. So we're going to go along the table at 45, and we go down. Oh my gosh, that's in my head a bit bonkers. I'm thinking 110. So that each in two. I'm saying 112. So if you get a conversion graph in your question, won't be hidden. It'll just be click on the icon below and your graph opens, and then to get rid of it, you just click on the icon again and it shrinks again. Those questions, I think out of the 4 papers that I've done the topic questions on, I think it's been twice where we've had to open up a graph. So they don't often happen. It's a case of quite normally they ask you to do the conversion themselves. So hopefully we've got a question. Yeah, we've got a question to start with. And apologies for not leaving much space for my workings out. It's sometimes, again, I've got a whiteboard, not in a classroom, on the screen that I split my screen with. So I kind of do often my scribbles on a whiteboard and keep coming back to the question, which this way, working on PDF is actually much better because when I save it, you've actually got my workings out on there. So we're looking at converting feet to meters. It tells us the conversion, and that's the good thing about all Pearson, NCFE, City and Guilds, TQ UK. At Functional Skills Level 2, you'll get a graph like we just showed page 4, or you'll get what the actual conversion is. So you don't have to know that 1 foot is 0.3048 of a meter. You don't have to know that, it will tell you. Or if you're converting pounds to dollars, it will tell you, pounds to euros. So all in all, when you're talking about conversions, it's about being able to follow a process using numbers, not have to think of a formula. So Josh drives a lorry, he's planning to his route. On the route, there is a low bridge. For those of you who live in South London, there's one that there's always a truck stuck under, and it's like, oh my God, every time I go that way, it's like, yeah, there's a truck reversing up the busiest road ever because it's got stuck. And the maximum height of a lorry allowed under the bridge is 14 feet. Maximum. Okay, so it can't be any bigger. 14 is as big as it's going to get. It wants to be this number here. Josh knows the lorry is 4.2 meters high. 1 foot equals 0.3408. So we know that 1 foot in meters is 0.3048. We've got 14 of them. So under our 1, we're going to put 14. So as you can see now, he knows the lorry is 4.2 meters high. We don't really have to worry about that too much yet, because if we know that the bridge is 14 feet, we can, if we look at those two numbers, we times that one by 14, because we said the feet of a bridge. The height of a bridge in feet is 14. So when we do the same to the other side, times by 14, it's going to give us the equivalent height in meters. And then we know straight away, if it's less than 4.2, it's going to crash. If it's more than 4.2 meters, it's going to be okay. So we're going to times 0.3048 by 14, because that's how many feet it is. And we've got 4.2672. Wow. Okay, 4.2672 meters. So now you can see that his lorry is 4.2, and the bridge, as much as if you think about 0.06 of a meter is 6 centimeters, it's going to fit. He's going to have to go pretty slow and not hope he's pumped his tires up too much, but yeah, he's going to fit. And so will he fit? Yes. Show how you think this. Well, we've shown them that the bridge is actually at 14 feet is 4.2672 meters, and his truck is only 4.2. If you think about converting it the other way, you think, oh, well, could we have done it somewhere else? Yes, we could have looked at converting this number, the height of his truck, into feet. And then if it's less than 14 feet, we know it fits under. So if we'd have looked at it that way around, we're going to go, oh, where am I going to go? I'll stick it over there. 4.2. And if we now divide it by how much each meter is worth, how much each foot is worth, we'll know how many times that number goes into 4.2. So we're going to divide it by 0.3048. And now we know the height of his lorry in feet is 13.779. So you could have done that question both ways around, because it's asking you, will it fit under? Show why. So we could show either the bridge is higher than his truck by converting the bridge height into meters, or we can show that his truck is lower than the bridge height when we've changed the lorry from meters to feet. So you can do it both ways on that sort of question. And for 2 points, you know, they're not looking for you doing it both ways. They're looking for one way and then get out the other side, because literally you've got 1 point to show your workings and then 1 point to say yes or no, because sometimes the questions are no. And what is the next one? And there we go. Yes, the lorry will fit under the bridge. Oh, why have I not even got the answers in there? I'll tell you why, because on the when I've got it on PowerPoint, when I click, the answers come out in my screen. So I'm thinking, why are my answers not on the next page? Another one, when we look at meters, kilometers, we often have a question when it comes to meters and kilometers with the scale question. It'll say not me, but Steve's going on a bike ride and he's going to go from point A to point B, and each point is worth, each square on the grid's worth 10 miles. He thinks he's going to go 64 kilometers. Is he right? So we're going to have to look at the scale drawing, work out how many squares he's going when it comes to the miles, and then convert miles into kilometers to get your second point. Those of you who were here yesterday should really remember this question because we did it yesterday. So I'm not going to do it again, but the process of this question was 6 pointers, so a large question, the largest ones you're going to get in an exam. Did I put it on the next page? I think I did. That was in like not the writing, but more space to work out. And there was only a set order we could do this question. Like the other one we just did, we could do both way around. This one, there's a set order. Because if you look at the way the question's asking you, he's getting wire fence. He's telling you, he's going to go all the way around his garden, for starters, and it's in feet. And then we're looking at the rolls of fencing. It's sold in meters. So there's your first conversion you've got to do. You've got to work out the perimeter and then work out the conversion into meters. Once you've worked out your conversion into meters, the second part of the question is we can work out how many rolls of fence we need. And I think it was 3 points something, so we needed 4. And once you've got your 4 rolls of fence at a cost of €138, 0.50 cents each, we times 4 by 138.50, and we have a price, a full price in euros, and then we convert the euros into pounds. So this question has got 2 areas of conversion, 1 meters to feet, 1 euros to pounds. And once we've got the pounds, we can then say, would it cost more in the UK or France? And the question was, it was going to cost him more in France, I remember, because I said you've got to get it over there from England, which is great. And there'll be more questions like that further in this presentation, but if I'm going to leave this one blank, purely because when you do get the PowerPoint, the PDF on the email when it comes out, you've got loads of space or you've got loads of paper to have a go at that one without actually seeing my workings out from today, unless you've got yesterday's already saved as well, and then you can look back at how I did it yesterday. But it'd be a good challenging question because a 6 marker is the hardest question you're going to come across. Liters to gallons. We have had liters to gallons when it came to that American costing question about driving across the Route 66, we're going to get petrol at that place, and we're going to work out how many gallons and convert it into, and that was double conversion as well, because we had to work it out into pounds, not dollars. But we've got one similar here. It's a 4-pointer. It's got, straight when I look at it, I'm seeing miles, I'm seeing gallons, I'm seeing liters. So we haven't got, I think we've only got one conversion, but if we do it properly, we'll find out because it's will he spend. So Wesley's a salesman. He wants to work out a total cost of petrol he would use for the travel next week. Wesley knows he will drive a total of 520 miles. His car uses 1 gallon of petrol per 28 miles. Petrol costs 128p.4 per litre. 1 gallon is 4.55 litres. Then it has, will he spend more than 100? So that's the justification bit. Look at this question, how will we tackle it? Well, we can see he's going 520 miles. So that's the first thing I'm taking from this question, 520. And then I can see for every 1 gallon, I'm going 28 miles. So if I divide 520, the total distance I'm traveling, by 28, that's going to give me number of gallons. Once we've got number of gallons, that's the first part done, because the next part is talking about litres. So we're not really, we can't do the litres part or the costing part until we've done this. So this is one of those questions where, again, like the one with the fencing in France, we have to figure out the order we're doing it in. What? Really? 520 divided by 28. Okay. Number of gallons. 18,571. 18.571. Sometimes bugs me about these questions. Why can't it be just like a normal question? Maybe when I've times it by the litres, it'll be okay. So I know that I've got that many. Actually, I'm going to keep that whole number in my calculator. I'm going to put that because I now know that's my number of gallons. I know that for every 1 gallon, I've got 4.55 liters. So my big number in my calculator, I'm just going to times by 4.55. So I know that for every 1 gallon is 4.55. So I need to times my 4.55 by the number of gallons I want to use. So while I've got that big number in my calculator and I can't remember it, so I'll type it in a second. I'm going to put times by 4.55, and this is going to give us the number of liters. Aha! So it has given us a more rounded number. Had I rounded it up too early, maybe I wouldn't have got that number, would I? 84.5. So it's a much more rounded number. And again, the examiner, if you'd rounded it up at that first point, they wouldn't have been like, oh, you're not going to get any marks for that one. They would have seen you rounded up. As long as you stick to your kind of rounding and you sort of doing it to 2 decimal places each time. Don't sort of do 2 one place, then I'll do 3 and then I'll do it 1. If you're going to do rounding, even though it doesn't ask you to, try and stick to like 2 decimal places, because if you're talking pounds and pence, ultimately pence is the 2 decimal places in it, 94p, 62p. So the point when it comes to decimal places, when we're talking money, 2 decimal places is absolutely understandable. So we know we're going to use 84.5 liters of fuel. We know that our fuel is going to cost us 128p. So 84.5 times by 128.4. This is in p equals. Okay, so pence to pounds times by 128.4. So it looks like we're going to spend an absolute fortune on petrol this week, but don't forget this is p, pence. There is 100 p's in £1. So for this number to convert from pence to pounds, we must divide by 100. If we need a calculator, absolutely do it. If we know that we can just bounce decimal place 2 places to the left when it's talking about dividing by 100, we can see that it will be costing £108 and 49p. Well, with the earnings, so that'll become 50p. Okay. So the answer to the question, is Wesley correct? He thinks the petrol user will cost more than £100. Yes, he is correct, because it's going to cost him £108. Obviously, if you'd have had your price at £10,849, you would have lost a mark for that, because that's not accurate. That's in p, and you just, oh yeah, of course, of course, 10,000 is more than 100. Make sure you've looked at the conversion again. I know we had a conversion from gallons to litres, which was the number, but then we had a conversion of breaking down pounds from pence. And there we go. That's where the answer would appear. Pounds to kilos. Question on pounds to kilos. There has been a few cooking questions popped up. Using the recipe to bake sometimes is necessary. Sometimes you just wing it, don't you? It tastes the same, especially when you're cooking. No, baking maybe not, but cooking, yes. Kevin wants to make cupcakes. He has the list of ingredients. Kevin wants to make 300 cupcakes for his school fair. 1 cup of sugar is 7.76 ounces. Kevin has 3.5 kilograms of sugar. Does he have enough to make 300 cupcakes? Well, when we look at that question, I'm thinking, gosh, do we have enough information to answer this question? Because a cup, kilograms, ounces, 300 cupcakes, how does it all fit together? And first of all, it fits together because 1 cup equals 7.76 ounces. Aha, I see over here how much sugar I need to make 12. At the minute, I wouldn't work out if you think about 5/8, okay, and we work it out as a decimal, for example, 5 divided by 8, and then looked at the 12 cupcakes. So we divide 12 by 12 to get 1, and times by 300. We're not going to get as a fraction, it's too complicated to work out that when it comes to 300 cupcakes. So if we work out how much that is in real weight to start with, then we'll know how much sugar we need for 12 cupcakes. And then we can work out how much we need for 300. So 5/8 of a cup of sugar. Okay, so 1 cup of sugar is that. So we've got 7.76. Oh, not 8. If we divide that number into eighths, we have 1/8. We want 5 of them, so we're going to times it by 5. And that'll tell us in ounces how much sugar makes 12 cupcakes. So let's do that. All right, so we're going to go 7.76 divided by 8. And this is a 6-pointer again. Like I said, this is the max. So we know that 1/8 of a cup of sugar is 0.97 ounces times by 5, because we want 5, 4.85 ounces. So if we put 4.85, I know we're going to put in 4.85 ounces, okay, makes 12 cupcakes. We want 300. So for 300, we've got the amount for 12 here. If we divide it by 12, we know 1 cupcake. So once we've got 1 cupcake, we just times by 300. So instead of putting equals 1 cupcake there, it's in theory 4.85 divided by 12 times by 300. That's going to give us ounces. And then the conversion comes into place in a second. So this one's a tricky one because it's not real conversion there. It's just understanding amounts. We're talking fractions. So we're going to divide that by 12 to find out what 1 cupcake. So we need, wow, 0.4 ounces of sugar to make 1 cupcake. Not in my cupcakes. My cupcakes are much sweeter than that. Times by 300. So we need 125 ounces. 1.25 ounces to make 300 cupcakes. I'm not entirely sure. Did I press the wrong button there? 485. Right, divided by 12. Yeah, I thought I pressed the button wrong. I just don't know why it just didn't feel. Oh, times by 300 times by 2. Oh, I am going wrong now. I need to times by 300, not 100. 4.85 divided by 12 times by 300. Gosh, times it by 100. Right, there we go. 121.25. We're bang on now. We're back on track. So we know it takes 121.25 ounces to make 300 cupcakes. He's got 3.5 kilograms of sugar. As you can see here, for every 1 gram, we've got 0.035 ounces. We want to convert our ounces into grams. If we look at that number's bigger, so how would we make this number bigger? So we need to get that number here. We've got 1 to 1.25. We can only do one of 2 things. One, we can multiply. So we can multiply our big number by a little number. If that happened, that number's going to get smaller. So it's not the right way to do it because this number is bigger than that one. So if we divide our number, our big number, by the amount for each, oh my gosh, each ounce, we're going to get a bigger number here. So let's do that. We've got 121.25 divided by 0.035. If you accidentally 3464 point, give me just the first 228. Okay, if you by accidentally weren't 100% sure which way around to do it, if we'd have done it the other way around, 121.25 times by 0.035, and then put that down here, right? So you'd have looked at that and thought, oh, how can how can 121 go to 4.24 when actually this number on the left-hand side has to be bigger because 1 gram is more than 1 ounce. 0.035 is 1 gram. So we need a number that's bigger. So if you'd have got a number smaller at this side, if you'd have multiplied it by accident, you can clearly see when you get to that doesn't look right because it should be much bigger than the number I've got on the right hand side. This one is, but as you can see, we've not got any conversion to do, but we've got to smarten our answer up because that one is in grams. If we think about as 1,000 grams to 1 kilogram, we need to divide a number by 1,000. Of course, yes, we can use a calculator. If we think by dividing by 1,000, we're bouncing 3 places. 1, 2, 3. You can see it's 3.46428 kilograms. We've got 3.5. We've got enough. Yes. Doesn't ask you how many cupcakes he can make with his sugar. He just asks you, has he got enough to make 300? Yes, he has, because he only needs 3.46. A big question that's involved, and I'd probably say on a difficulty scale for a 6-pointer, that's quite high up there because, and there's only one because of that very first part. If it told you at this stage here that it was 4.85 ounces, then the question becomes like a 3-pointer or a 4-pointer, and there's not a lot to worry about. Because it has a fraction already in there, thinking, whoa, gosh, I don't really know what to do. It has a fraction in there. That's where we're linking it to this line of the question where 1 full cup of sugar is 7.76. So we need to work out what 5/8 of a full cup is. And oh yeah, full cup 7.6. So that part for me is where this question becomes the difference between a 3 and 4 point question to being a 6-point question, because we're looking at not conversion, but we're looking at adapting a number that states its quantity in a fraction to what it actually is in ounces. So that's why that question's a 6-pointer, in my opinion. Asking as an examiner might say something completely different. Okay, hopefully we've got more questions coming up because we're looking at not BIDMAS. Hopefully, are we looking at BIDMAS? Where should we look at BIDMAS? Hopefully, we've got some questions that actually tell us distance. Where's the exam questions? Come on. More conversion. Fahrenheit to Celsius. This is better. We've got Fahrenheit to Celsius, and there's a question I think on one of the atom assignments, I think it is, or I think it's the mock exam actually, that says a temperature in Greenland is X, a temperature in Iceland is Y, as in like minus something, and then but one's in Fahrenheit, one's in Celsius, and you've got to tell me which one's the warmest or which one's the coldest. I can't remember which way around it says. So on this one, very similar. We've got one temperature, and it's not conversion when it comes to kind of like a straight swap, when it's like 0.3 is a foot or 0.3 is an ounce. It's giving you a formula to follow. So it's the same principle as in we've got one number at one end of the machine, we put it in, do the stuff, and it spits out another number at the other side. And it's not just as easy as saying, oh, it's times by or divided by 0.3. It's actually a formula we've got to follow. So let's have a look. Ruby is going on a holiday with her family to Mexico in December to celebrate the festival season. Did a Festival of the Dead have that one? The forecast temperature is 79 degrees Fahrenheit. Dev tells Ruby to take a woolly hat and some gloves because December is always cold. Wow, maybe not in Mexico. And 79 doesn't seem too bad. So we're going to take our hat and gloves. Is he right, and why? Well, 79 degrees Fahrenheit might be cold for some people. So maybe Dev just feels the cold. So we're going to look at what it is. We don't know what the C is, but we know what the F is. So the F is 79. We know we've got to take away 32, and that's in our brackets. And then we times by 5 ninths. Well, is that not like saying divide by 9 times by 5? So rather than look at it like that, We can times by 5 nines, absolutely. But to times by 5 nines, I'll show you what I will do in a minute. But first of all, and it's a calculator paper, we do 79 take away 32. So we'll line them up properly. 79, 32. 9 take away 2 is 7. 7 take away 3 is 4. So we know our bracket represents 47. And it still says times by 5 ninths. Okay. How are we going to do that? Well, I'm going to do 5 ninths, but as a decimal. So to do 5, that's a fraction. And we know to get any decimal from a fraction, we do top number divided by bottom number equals our decimal. And the reason I'm going to do that is because then I can just times it by 47 because I know what my decimal is as 5 ninths. But I'll show you what I would do if it wasn't set out. Sometimes it shows you in a different, slightly different way, depending on what exam you get, weirdly. 5 divided by 9. We now know that's what 5 ninths represents. I'm going to times it by 47. Okay, so 26 degrees, that's all right. You know, 26, not gonna turn your nose at that one, are you? So 26.11 degrees Celsius. We're okay with that. We don't need to take a woolly hat and gloves unless you want to protect yourself from the sun. So we've got 26.1. If you're a bit unsure about 5 ninths, it's 5 divided by 9, then that's just me again looking at 5 ninths as a decimal. We would have done 47 divided by 9 times by 5 because we want 5 ninths of that number. So if we divide it by 9, we get 1 ninth. Times it by 5, we get 5 ninths. So when it says times by 5 ninths, don't be scared of looking at that as a fraction because it is a fraction. But if we break it into 9 pieces, that would give us 1 ninth, but we want 5. So we times it by 5 and we get the same answer. So we'll do that. 47 divided by 9 times by 5. And we've got the same answer. So we've kept it as a fraction and worked it out. Or we've changed our fraction to a decimal by doing 5 divided by 9 first and then multiplying the bit we got in our bracket, which is exactly what it's asking us to do there. And it's not going to show me the answer because I can't click next screen because it's underneath that green box. So you've got to trust me, it's 26. And I think that's quite one. I'm all right with that. Work out the value of x plus 3 when x is 2. Oh my gosh, we're getting like a whole bit of algebra here. Well, we're not. It's substitution, isn't it? It's substitution. So this is not algebra. Straightforward questions where we've got 4x. When it's packed next door to it, it's multiply. 4 times 2, add 3. Well, we know that multiply when it comes to bit mass, it's not a bracket, it's not an indices. Aha, it's a multiplication. So multiplication comes before addition and subtraction. So it becomes 8 add 3, and that will be 11. At this one, when it comes to, I mean, I've never, in all the exams that are on the NCFE website, so for the last 4 years at least, there's not been a square root to work out with letters. Okay, but this one gives us a square root. Okay, so this is even older than 4 years. Square root of 16. So when we see the little square root sign over the top of a number, it basically is generally, if it's going to be an exam that's at level 2 and it's non-calc, it'll be a whole number that's a square number. So think about a number times by itself, we'll get to that. So 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5, 25. So generally when we see a square root sign, it's the opposite of us seeing that. So when we see 4 times 4, we know, or 4 times 2, no, 4 times 4, 4 squared. So 4 times 4 is 16. When we see the square root sign, it's not the bus stop. We've got literally a number in here. So it means something times by itself equals that number. And generally, like I just said, it's going to be a number that we recognize as being a square number of a part of our times table. So from 1 times 1 right the way through to 12 times 12 at 144, you're going to have one question in the last 5 years. Is it worth knowing? You can store it in there, but it doesn't come out very often. However, we've now done the square root of 16 and found out it's 4. And we've got to times it by 5. So it becomes 4 times by 5. That's 20. And so we do the bracket. No, the indices. That's an indices. That's like giving you an instruction to do so. The 2, that's an indices, and that's an indices. So when we see that, it comes before multiplication, division, addition, and subtraction. Hopefully, what have we got now? Here's the formula. P equals. How about in proper questions? All right, let's go to proper questions. Oh, here we go. Cooking, my favorite. Give me another 7 minutes, then that's what I'll be doing. Johan is cooking using an old recipe. The recipe says to preheat the oven to a temperature of 350. And then another question on one of the exams that says that somebody set an iron to the temperature, and he set it to using Celsius and not Fahrenheit, and he's either burnt his clothes or he set it to Fahrenheit and not Celsius, and he's not got his clothes hot enough. It says, how much more does he need to turn his iron up by? Very similar. We're talking ovens, not irons. And so the recipe says to preheat the oven to 350 degrees Fahrenheit. And go, we don't put it 350 C, that's going to 2 up, mine goes to 220. The oven Johan uses marked in centigrade. Defines the formula to change Fahrenheit to Celsius. And so this is it. If you look to here, look. Oh, it's gone back. The question we just thought to change Fahrenheit to Celsius is slightly different. It's the same thing, but it's given as a slightly different way of doing it. And again, it's not to say, oh, it's wrong. It's not wrong. It's just a different way of doing it. It's just the way the order of operations are just slightly changed. It's still that bit in the middle, wasn't it? But if you look at it, it was, if we just put it on, it's F take away 32 in a bracket times by 5/9. That says 5. That's exactly what that is. Because we've got F take away 32, or then we times it by 5, divide by 9. So they've just done theirs a little bit differently, but it's going to give us exactly the same answer because it's the same process, but in a different order. Okay, so he's got 350 degrees Fahrenheit. He's taken away 32. Okay, so, and then we'll divide it by 9. And then, we've got to times it by 5. So we do the bracket first. So the bracket is here. 350 take away 32. If you want to do 50 take away 32, that's 18. So we keep the 300 and we're now on 18. We're timing it by 5.
Steve, you know, on an exam question, sometimes it don't show you this, well, mock exam. It doesn't really show you this, you know, diagram bit. It just tells you the words.
Yeah, it should do. It should give you kind of like the formula. It might give you, yeah, you've maybe got to, you have to find the question. Yeah, I'll have to have a look at it. But I'm sure it does give you, maybe not that exact one, maybe the one above, or it might give you like the step by step. So it'll say square number 1, put in your Fahrenheit. Oh, then times it by 4. Oh, and then something else. So it might give it in words broken down. Sometimes they give you like that formula to follow. But generally, you won't be asked to remember anything like this. It's a case of, can I follow what you've asked me to do? So times by 5, divided by 9. We know he's got to whack his oven on at 100 and what? 176.666, and it goes to an end. Johan sets the oven temperature to 190. He's going to burn his chips. Johan has set the oven to the correct temperature. No, he's not. Set it too high. We haven't got 3. Oh, we've got 3 minutes, but I think that's the last question anyway. That's good. And if these sort of sessions, I'm happy to go halfway through, as in like not just do the exam style questions and try and pick out some of the other bits. But if giving you these full PowerPoints, okay, the PDFs now because I've changed them, but if giving you those PDFs are useful because you can see kind of you can read the bits in between, then I'm happy to do that. I'm happy to kind of break it down and spend 2 lessons doing one. I don't mind. But what I would say is, if you want it where the answers appear, then I will have to share it. 'Cause I think they're huge. Let me just double check. How big are they? Even as a PDF, it's over 2 MB. I don't really know. I'm not very good on computers, but yeah, as a PowerPoint, it's over 21 MB. So it will just block everybody's inbox up. So I'll keep sending them out as PDFs. I'll send the recording out. But what I would say, if people want me to break things down more, not more slowly, that's not the wrong word, in more detail, then please let me know, because I'm happy to spend more time doing the kind of the fillers, the slide fillers that's telling me what the process is and things like that. I'm more than happy to go through those sort of things. It's just choosing a topic and trying to get everybody familiar with process